Too bad you're playing football. All right, put that off to the side. You're not going to get it till later because you're going to be distracted otherwise. But you will get it before the end of class. Here we go. Yesterday. Yes, they are. No. You need to correct it. You need to learn from your past experiences. You need to take those reflection sheets and apply them, the action plan, to how you can improve your studying. Okay. We talked about the basic derivative rules. Constant, derivative of any constant is 0. Power, derivative of x to any n, you bring down the n, you take away 1 from the power. Constant multiple, if there's a constant in front, no big deal. He stays in front, and he gets absorbed, like in this power rule. He gets multiplied by the n that comes down. Sum and difference, we can take the derivative of each separate part of the sum and difference and then put it all together for the final derivative. Derivative of sine is cosine, derivative of cosine is negative sine, derivative of e to the x is e to the x. Woo! There they are. Okay. Today we have to learn how to use them. Was this one pretty easy? We used the constant multiple rule and the power rule. Constant multiple, negative 3 stayed power. The 12 came down to multiply by him, and then the power lost 1. This one, constant multiple rule. The 1/2, he's just a constant. He got to stay. But then sum and difference rule, we took the derivatives piece by piece. Derivative of x to the 4th is 4x cubed. Derivative of 7 is 0. Put it all together. Dun, 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 dun. How is he harder, though? What did I do before I ever did any calculus? Take up the radical to a 1/2 power. Use exponent rules to put them together. How did I get 3/2 from 1.5? Oh, 1.5 is 3/2. But when I multiply like bases, what do I do with the exponents? When I multiply like bases, what do I do with the exponents? When I multiply like bases, what do I do with the exponents? Oh, it's like we're getting quieter. Anyway, we add them. I'm trying to keep you awake. So 1.5 is 3/2. Or, wouldn't it be easier to think of the 1 as 2 over 2? What's 2 over 2 plus 1 over 2? But, was I done? Oh, it's such a struggle in calculus, because sometimes you have to do so much work before you even get to the calculus. And some people will be like, whew, that was hard, all right, and move on. No, you're going to do this. I'm not kidding. Okay? Do you see the struggle? You're like, oh, I have to think. Whew, I must be done. No, keep on thinking. Don't give up. Got to persevere. And persevering is also reconsidering and saying, who is this guy? Oh, it's still just y? Who do you need? dy dx. So you take this guy and say, okay, well, that was fun and all, but that was just what we're going to call rewriting. That's just rewriting him in something I actually can use my rules to. Now, how do you use your rules? Bring down the power. It gets multiplied by the 5, 15/2, and then you have to take away 1. Wait, where's the 1? That is 1, but why am I doing 2 over 2? To make it easier on my brain, negative 1/2. Why didn't I stop there? I could have, but why did I rewrite it again? Was there a 1/2 power to begin with? Yes, but not written that way. How was it written? It was written as a square root. I see it. Thank you, my ones that found the mistake. Good job. Thanks for letting me know. But at the very beginning, there was a square root. So I'm not supposed to end with this power. Now, some of you are like, wait, your math was wrong. You're right. I was going really fast. What's 3/2 minus 2/2? Positive 1/2. So how am I, good practice, how am I going to rewrite in a way where I say, wait, it started with a radical. It should end with a radical, but with a positive 1/2 instead. What's my answer going to look like? You could do 15/2. X what? Okay, you could do it that way. Or couldn't you also do it 15 root x over 2? Are they the same thing? Yeah. Either way, I need this guy to be in the top, not the bottom, because he was a positive. 1/2 power when you subtract. Good job, guys. Good job. So, here's where we are going today. Harder problems. Sometimes it can be very helpful to rewrite first before deriving. The rewriting step is not the deriving step. I'm trying in your brains to separate the two ideas. That way you won't do all the work rewriting and think you're done, you'll know that you're only done rewriting and the deriving has not started yet. So rewriting is not deriving. Sure, it takes math. But the derivative is not done until you have done the deriving. Kind of like the limit is not done. Ooh. Kind of like the limit is not done until the final plug-in, which is why we cannot stop writing limit early. Same thing with deriving. And so maybe I'll try to help just a little bit in that process. So let me give you some original functions. But we're just going to do them one by one. Maybe I'll go one ahead, so if someone does finish early, they can start the next one. But I'm not going to write all of them down. Let's go ahead and say the original function, which is y equals f of x. Ryan, go ahead, bud. What's up?
I thought you didn't have to simplify for like.
Well, pause. We haven't talked a lot about it. But I have brought up the phrase stick it to the man, right? Which is like you can stop. But then I've brought up two very important times when sticking it to the man is not enough, okay? One is if it's you checking the back of the book to see whether or not you're right. You have to be able to take your answer, compare it to the back, which might have been simplified, and you have to know whether or not you're correct in grading. Does that make sense? So one way is for you guys specifically, whether through CalcAB or the back of the book, whatever you're grading, or even in class, you have to be able to match your answer. And so when you're doing homework, it's going to be a smart idea to simplify. Otherwise, grading will take you way longer, and you might not truly know if you got it or not. That's important reason number one to simplify. Important reason number two to simplify. Half of the points on the final AP test are multiple choice questions. And guess what they do in multiple choice questions? Yeah. Now, they don't always simplify as much as you think you need to or as much as you might do, which is why when you actually have a multiple choice question, I train you guys to look at the answers first just to see what form they are. That sometimes guides you as to how much to simplify so you don't waste time. But if half the test is multiple choice, we have to learn how to simplify too. Yeah. But on the long answer, the FRQs, when we're having to write all these like sentences and explanations and stuff like that, we do get to leave the math alone as far as get the answer in its roughest form, box it, and be like, you figure it out. Stick it to the man. All right, here we go. Original function. Let me give you a few. What if I was to give you something similar to the last one? Let's do something like -2 cubed root of x squared. And if you guys finish that one early, I'll give you one more to start playing with. Let's do -5x squared plus 1 all over x. Ooh, that's fun. That's fun. Now, if we're trying to get to the derivative, if that's our goal for all of these, the directions would technically be find f prime of x. You're given an original function. To find f prime of x, if we have the original, technically we should put in something like a ddx, right guys? Verb. I need to take this guy's derivative. It's not enough just to have the original function. And in the rewriting step, we still have, because we haven't taken the derivative yet. But has anybody thought through how I could rewrite this expression in a way that my basic rules would help me differentiate? Got it. -2 times x to the 2 over 3. Now I can stop writing d dx and I can just actually start doing the deriving process or the differentiating process or the finding the derivative process. So how does the power rule work? The -2 chills, right? Constant multiple. What happens to the 2/3? Bring it down. What happens to the power? Subtract by, don't say 1. 3 over 3. Do you guys get it? Makes it easy. on your brain if you train your brain to change that 1 to whatever denominator you need. So 2 over 3 minus 3 over 3, wouldn't that end up being, I put that little 2 over 1, right? Negative 4 thirds x to the negative 1/3. Now, Ryan, for right now, I'm going to stop there. But, in reality, a back-of-the-book answer or multiple choice answer, if it started in radical form, would probably end in radical form. So they would put the x in the denominator and make it a cubed root. Does that make sense? But for right now, I did simplify enough that I can see my answer pretty clearly, hopefully. Now, this one. I need to take the derivative of this guy. And you take the derivative of this guy. How can I rewrite? Now, wait, pause. Look back in your notes real quick or into your forever cards. Basic rules, basic derivative rules. We have one for adding, subtracting. We have one for multiplying by a constant. We have one for sines and cosines and e to the x's. We have one for basic power rules. Do we have one for quotients? And from the summer packet, do you remember there was a really special complicated rule for quotients? There's something called the quotient rule. We haven't learned it yet. So we're not going to do this with the quotient rule because there's another way. We could rewrite it to make it fit the basics. But how? You could make x to the negative 1. The problem is then you have a product. And we haven't done the product rule either. In the packet, yeah, but not yet. There's a way to use the basics. If we did make it x to the negative 1, wouldn't multiplication be distributed? And what would be x to the negative 1? Wouldn't that be the same thing as multiplying by a 1 over x? Why do kittens die if I just go canceling out? Real quick, this is totally wrong. I'm doing it in a blue marker. It's not even in my red. Why did a kitten just die? Some of you kittens died. Oh, kittens died. Coming back. Because this whole thing is being divided by x, right? So doesn't every single term need the division? It's not just him being divided, it's also the 1. So the reason why that's horribly illegal is because you need to distribute the division. Distribute the multiplication by the reciprocal. So how do we distribute the division? Do you guys see how this is the exact same thing as negative 5x plus x to the negative 1? Pause and think. If I divide both terms by that denominator, it's legal. I just need to distribute the division. I just need to see the entire binomial in the numerator as being multiplied by 1 over x. And if I take this one 1 over x, you're right. 1x does go away, but it's not enough to do that. You also have to divide him by x. Wait, why did I write it like that? Why isn't it 1 over x? I want my power rule to apply. 1 over x, no power rule, but x to the negative 1, psh, I got it. Do you got it? What's the derivative of negative 5x? Ooh. Can we go back to our basic rules real quick? Some of you guys need to get faster on this one. And let's do it here. If I zoom in on my basic power rule, okay? If I zoom in, can I do a quick example here? Maybe you do it off to the side. What would be the derivative of just plain old x? What would be the derivative of plain old x? Which constant multiple could be x or 2x or 7x? Why is it 1? You bring down the 1, x to the 1 minus 1. And what is anything to the 0 power? 1. So whenever we just have an x term, it's just going to be the number in front. Wait a minute, that makes sense because derivative is verbal description. What's the description of a derivative? Slope of a tangent line. Wait, what's the slope of any linear function? Oh, it's the number in front. Oh, so go here. What would be the derivative of negative 5x? It's a little linear piece. Yeah, it's just negative 5. Negative 5 times 1, technically. So we have negative 5. Without doing all the math of bringing down the 1, and 1 minus 1 is 0, the x goes away. Remember, anything to the 0 power is still a 1. How do I take the derivative of this piece? Bring down the negative 1, x to the negative 1 minus 1. Ooh, what's negative 1 minus 1? So it'd be minus. Can I make this 1 over x squared? Are you guys okay? So I could leave it x to the negative 2, but like in this problem up here, how I mentioned that they could rewrite it, that could also look like 1 over x squared, and that's totally valid. This could also look like negative 5x squared minus 1 all over x squared. They could get common denominators. Here's where a struggle, a very common struggle in calculus comes up. You could have a right answer, and it looks very different than the one they give you, and you have to be able to make it match. Ugh. You guys didn't really face that too much on the limits test, but starting with the derivatives test, making it match is not always so easy. All right, letter C, let's get a couple more. What if I was to give you something like, what's something else you guys could see? How about this? What if I was to give you, oh no, you won't be able to do that yet. How about x squared plus 1 times 3x minus 1. That's good. And then how about for letter D? Let's do something like, oh, you couldn't do that yet either. Let's do 3 sine of x all over 4 tangent of x. Aha! You're welcome. Okay, we saw it in the summer packet that there is something called the product rule, but I'm saying this is possible to do with basic rules. And in section 2.2, you're not meant to be using product or quotient rules. So, how could you solve this if a product is not allowed at this point? How could we rewrite it if a product is not allowed at this point? Foil it, good. Good, that's the right word. Foil it. How would I foil if, oh, well, I mean, there's just 2 and 2, right? So whatever. Let's go ahead and do some. Now, just a few of you might be like, ooh, that's a 2x, that's a 0, that's a 3, that's a 0. Put it all together and you're horribly wrong. Remember, summer packet, there was something called the product rule. There's a very specific way to deal with products, and you can't just take the derivative piece by piece. There's not a basic rule for products. So we'd have to do what Nick said, which was multiply. So we have our 3x cubed, we have our negative x squared, we have our positive 3x, and we have our negative 1. And we foiled, right? Because there's our smiley face with a big nose. Okay, so fun times from Algebra 1, teaching days. Now what? Are you getting quicker at these? What happens when the 3 comes down? 9. What happens when we take away 1? Nick already said it, 9x squared minus. What happens when we bring down the 2? There's a 2, and the x is now to the 1. What happens when we take the derivative of a linear piece? It's just the 3. What happens when we take the derivative of a constant? It's 0. Dun, 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 dun. Don't even need to simplify it. Go team. Why do you have mini whiteboards? Because you're going to try to go fast, in just a little bit. But together in a group where they can catch your mistakes if you go too fast or if you get stuck. Do you know?
I have a question for A.
Yeah. Oh, no, you take away 1. Like the 3 becomes a 2, the 2 yeah, but when you have the 2/3, taking away 1. Oh, right here?
No, because when you bring down the x squared and then you do times 1 over 3, I mean, yeah, times 1 over 3, you don't have that. So how do you get to it?
There could be an in-between writing step. You could make just this part x squared to the 1/3. You're thinking, where's an example? You're thinking like bases, we add the exponents, so x squared times x is x cubed. That's when we add. But when we raise a power to a power, there you go, we multiply. So 2 over 1 times 1 over 3. So it's not 2 1/3, it's 2/3. Yeah, good question. That's a really important idea. Guys, letter D. Why rewrite? No quotient rule yet. Okay. Can't deal with quotients unless I rewrite. Oh, just a few of you didn't even think to change tangent on the test. How can we change tangent? Sine over cosine. Do you guys see how rewriting d dx is keeping you honest so you don't think you're done earlier than you are? Okay, can I just make the 3/4 a constant? Is that legal? I think so. And then can I do sine of x all over sine over cosine of x? Where's the big fraction bar? Is it this one or is it this one? This one, right? It's sine over cosine. So who's my stuck little denominator? So let's multiply by cosine over cosine. And what do we get? Wait a minute. When we multiply by cosine over cosine, now all of a sudden we just have sine over sine times cosine. What happens to sine over sine? Oh. So is this really just 3/4 cosine? Mm-hmm. So sometimes it might take you a couple steps to rewrite. It might not happen real quickly. It might take you a little bit of time to get it, but eventually 3/4 of cosine. Hey, basic rules. What's the derivative of constant multiple? 3/4 is chillin'. What's the derivative of cosine? Go look. Negative sine. You can think cosine, the signs change. That was from pre-cal trig last year. There's a little different sum and difference properties, but that's okay. Dun, 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 dun. Okay, give me 1 second. Oops, let me give you a second. There we go. Let me make this a little bit bigger. Just in case someone was still writing. I need to see how many pages of notes we have, so how long we can spend on. I think you guys got it. Let's do this page. That way we finish our notes and then we can just play. All right, let's pull this page up. Beep, beep. One more notation-y page. And I think you guys have already seen me use it. I don't think this is new. But real quick, if we're trying to do finding specific derivatives, you guys have already seen me relate f prime of x at x equals a to be f prime of a, right? F prime of x at x equals a. A specific derivative, a specific slope, or a specific rate. F prime of x at x equals a can be f prime of a, or it can be f prime of x such that x equals a. Which is nice, because sometimes you can get a derivative and it's all messy, this whole formula. You can put this little such that x equals a, and you can start solving by plugging in. It just gives you a little bit more freedom for notation. So a couple more seconds. Okay, when you guys finish this page, I want you to go ahead and turn your desks so you can see each other. In your groups, turn your desks so you can see each other. Pick a person to start with, the marker and the paper. But you want to be able to see each other's desks. Close your notes with your pencil in it. Close your notes with your pencil in it. And here's why. What we're going to do on each of these is one person's going to have the marker and the whiteboard, one person is going to have to solve the entire problem, but the other people are allowed to speak in the sense of, no, I don't agree with that, or no, you should, oh, careful, that's a negative 1/2. Nope, that's a positive 1/2, subtracting, etc. So you can help each other, but only one person is allowed to have a marker the entire time for that problem. Does that make sense? And then the next problem, guess what? Marker switches, and then it switches again, and then it switches again. So that way we're taking turns around and around and around. But here's how it works. When you as a group, think you have the final answer, a correct answer, then I want you guys to go ahead and call me quick or hold it up so I can see. And if I agree, you're all putting it in your notes. Does that make sense? That way you not only work all together on it, but then if it is right, you solidify the fact by putting it in your notes, okay? All right, here we go. Today's not competition day. We're just kind of getting a feel for it. Tomorrow we're going to start making points in groups and all that sort of jazz. So here we go. On your marks, get set. Write down the problem first, but then you can put a ddx around it and start solving, yeah? First one to take a derivative of is the following. Okay, we're not stressing today. You can do ddx of the square root of x plus 1 over x. Work together on rewriting. Making sure the rewriting is good. Give him things like, oh, that's good. Or why did you? Or, oh, I think you can do. Say stuff like, oh, I see you're using the power rule. square root of x plus 1 over x. Square root of x plus 1 over x. Rebecca, hold it up. I have two groups that have checked in and gotten it right. I agree with the second to the last step. The rewriting is off. Help, help, help. The rewriting is off. It's illegal to put those two together because it's not multiplied or to a power. Adding it has to be like terms. So take this. This was perfect rewriting, but you have to take the derivative piece by piece. Does that make sense? Okay, so use that power rule. Yes. Open up your notes. Get it done.
She said she agrees with this.
I said I agreed with that.
So the first one is 1/2 x. You go up now, power.
And you could think the square root of 1 is just...
I'm just guessing.
As you guys are writing it down, my groups that have gotten it right, make sure everyone understands each of the steps. So everyone's writing it in their notes. And then Ryan, you should be able to get it because I'll put it on the screen. Because you do your notes later, right? You pay attention in class.
Sometimes.
But today's one of those days.
No, actually.
Oh, good. Then get this one written down. Yeah, but what was the problem and what was the work and what was the... Yes, there you go. There you go. I mean, it's good that you did on the whiteboard, but you won't know a week from now what you did. You know what I mean? Yeah. Anybody else checking in? I'm going to give you my final answer. I'll leave it there. Yeah, I think so. You guys got it? You were really close. Go ahead and get it in your notes, kiddos. Good. Just careful. Plus a negative, you could make that a minus. Does that make sense? There you go. And then all you're missing is just me rewriting it. So I put the x to the negative 1/2 as a square root in the denominator, and the x to the negative 2 I put in the denominator. Does that make sense? Okay, go ahead and write it. Those of you guys that are done writing, this whiteboard needs to switch to a new person. It needs to be erased. Erased? Oh, who doesn't have an eraser? Pull one. Oh, you got one. Did you guys all think ahead? I'm so proud of you. You have one too? I didn't even say it. Oh, good job. Go team. Trained well. At least from 0 period days. Okay. Someone new with the marker? Someone new with the marker? Get it down in your notes, and as soon as you have it down in your notes, go ahead and close your notes again. Someone new, marker. Ready, set, go. X to the 3/2 plus 2 over x. Take your time if you're still writing in your notes. Get that first. Then close up your notes, and someone new starts on the problem. X to the 3/2 plus 2 over x. Take it away, cool kids. Take it away. You guys seen there's patterns about every time it's a 1/2 power, it's always going to pop there? Yeah, it's going to be helpful. Good. Lock it in. Talk it out if you need to. Lock it in. Everybody to write it down has to understand what they're doing.
This is by itself.
What are you saying?
We have an x squared to the bottom.
I don't understand what you're saying.
Good.
If you're ready. I love this one. I like this one. I disagree with how you simplified. Does that make sense? Think it through. Think it through. You have to distribute the division, yeah? Lock it in. Right, get it in your notes. Make sure everyone understands. Oh. Okay, hold on. I just saw, I didn't see where the mistake happened. This is written correctly to that. Now you guys have it written right. Here's the problem. I disagree with that. Because, wait, I erased more than I should have. I agree with that. If there's a times there instead. But I disagree with that. Remember, you're supposed to divide. So how do you do x to the 3/2 over x first? Because I think the 3/2 should be diminished somewhat, right? Like bases dividing, what do we do to exponents? Before you ever do the power rule. Sorry, the rewriting step was off. I missed it. get me an f of x. Who's doing it next, Michael? But hide it from Michael. When you divide like bases, what do you do to the powers? So it's still an x, but it's x to what power? Yeah. So now what? Does that make sense? The other part was perfect. Let me see. Yes. Okay, get it in your notes. Get it in your notes. If you have the marker, no, you're allowed to talk. Yeah. You don't have to be a puppet. You don't have to be a puppet. Yeah, not like last time. But you can't just silently like do the problem. Does that make sense? Like talk through what you're doing. Because otherwise you could just be ignoring your group altogether and they're like, we have no idea what's going on. But the nice thing is when you write it in your notes, you kind of have to know what's going on to write it down, right? And what each of the steps were. Okay. Here's what I'm going to do. I want you guys to go ahead and erase the whiteboards, turn your desk back straight. I'm going to get you guys tests. Whoever didn't go today is going first tomorrow, okay? On the way out the door, you're going to put them away. I'm going to pass out your tests. Here you go. Aren't there usually more princesses first? No? Oh.
Thank you and God bless Heritage.
Okay. Guys, this is test 1. Corrections will count for some points back. Some of you, to be nice, like in a very encouraging thing for the whole class, I think this might be the first year that it hasn't dipped into the 50s. No one dipped into the 50%, which was actually really good. All right, start pondering, thinking through corrections tonight. This homework isn't due till Monday, but wait, if tomorrow's competition, what had you better do tonight?
Study.
You better practice with some basic derivatives. I'll see you guys later. Just turn in whiteboards and markers to the front. Thanks, guys. Sorry, yes.
I thought I got a